Hello kids, welcome. Let's discuss today's JEE Mains question paper, and the chapter for this particular test was first halogen derivatives of alkane, second alcohol, phenol and ether, and the third chapter is aldehyde, ketones and carboxylic acids. So let's kids proceed with the discussion. I think so student, on the screen if you see there is one question given to you, what will be the major product of the following reaction? Now, I think so child, you must have gotten logic in this, that you have got 4-membered ring. So, this example would be most probably of ring expansion. But now, how to go ahead with the ring expansion? Let us see over here. Now, see, I have got a starting material, and I think so the starting material what you can see very clearly is this one, where you have got a Br group, correct? Now, due to water, I think so what will happen? It's a polar protic solvent. So, your dissociation can take place very well. So, here your Br will go out with the help of water, dissociation will take place, and what should be your answer? Wait, you will get nothing but the answer of this type, where you have got 4-membered ring, again you have got some branch, and this is the group, and from this position you have got Br left. So, can I have carbocation form? Now, the next situation, when you talk about carbocation child, you have got one more option, that your ring can expand over here. Now, when the ring gets expand, the structure what you will get is will be of this type. You have got 4-membered ring. Here you have got something called as and ethyl group. Now, instead of joining your carbon to this carbon, join this with this carbon atom. So, what you will see that you have got over here a positive charge. That means here what we have done, your less stable carbocation is being converted into more stable carbocation. Yes. Now, let us write this structure in one more way, which will be much more better and easy to write. It is a 5-membered ring. You can see 1, 2, 3, 4 and 5. So, can I put over here a 5-membered ring? Correct. And one more thing, you have got one carbon atom as a branch, and the immediate next carbon atom has got a positive charge. Now, you can do one more child, one more rearrangement. Now, you know that over here at this position, you have got one hydrogen also available. Yes. So, right now which is a secondary carbocation, can it be having an hydride shift to make it more stable tertiary carbocation? And what would be the structure of it child? You have got a 5-membered ring having a methyl group and having a positive charge over here. Now, what is the last step child? I think so you have got with you and water over here which will hydrolyze the situation. Hence, what will happen over here? You will get nothing but the answer is 5-membered ring having a branch carbon, and to this branch only I will have OH. So, the expected product for our reaction, I think so what you can see is nothing but the option C. So, correct answer for this MCQ is C. Yeah, let us proceed with the next question kids. Now, I think so the next question what you have got is nothing but what one of the alkene they have, alkyl halide they have given. Yes, and what is that alkyl halide if you see? It is CH3, CH3, correct. Now, you have got something called as C, then you have got CH3, one more CH3 which I will write it up, and one is Br. Now, the question is what? I have got over here 2 different reactions. Now, the first reaction what we have got is MEOK, I think so it is a potassium methoxide, and the second one is known as ET3COK. Now, before we start anything child, you should be aware of one important point. And what is that important point child? I think so that important point is this one is nothing but a bulky base, and always whenever there is a bulky base child, what will happen? You get least alkylated alkene as the Hoffman product as a major one. So, now as per the concept, this becomes your alpha carbon from which the leaving group will go, and from this position your H will get lost. So, the answer what we get in this example as the second category is CH3, CH, CH3, here you have got CH3 and here you have got double bond with CH2. So this is least alkylated alkene as a major product, or we call it as Hoffman product. And I think so as per this option, if you check, yeah, the second option Y, in this case, yes, is it exactly matching? Correct? In this case, it is not matching. Second option, second compound Y. In this case also, if you see, it is not matching, and in this case also it is not matching. That means if you see that solving only one of the product only, you can get your correct answer. So your correct answer in this case is nothing but A. I think so. Is it clear? Let's proceed to the next question, child, what we have on the screen. Now, I think so what they have given is nothing but which of the following compound gives fastest SN to AR reaction. Now, before we start anything, child, you should be aware with one case. This is known as SN AR type of reaction. That means it's a aryl, yes, nucleophilic substitution reaction. Now, when you talk about benzene, we have done somewhere in past that benzene likes to undergo electrophilic substitution reaction, correct? So, yes, what about this when you see? If you know that there are two types of groups in the nature, one is electron donating group, other one is electron withdrawing group. Now, which groups are donating and which groups are withdrawing? Obviously, donating group means the one which will give electrons, so they themselves will become positive. So, these groups will be all where you have got positive effect, maybe positive I, maybe positive H, or even a plus R also is okay. Whenever you talk about withdrawing group, basically these groups are the one which will take electron. So, यहाँ पे you will have nothing but minus I, minus H and minus R types of groups. Now, the question is, you must have studied a reaction of benzene very well. They are undergo which reaction? Electrophilic substitution. And in electrophilic substitution, child, you know which group enhance electrophilic substitution? It's an electron donating groups. Enhance electrophilic substitution. But now question is, we don't have electrophilic substitution. We have nucleophilic substitution reaction, which will be exactly opposite of this. That means which groups are there which will increase and which groups are there which will decrease. You can make it very clearly. So, which groups are there which increase a nucleophilic substitution of aryl halide? It's nothing but an withdrawing group. And I think so in our example, if you check, yes, we have got over here one electron withdrawing group. Here we have got two electron withdrawing groups. Here we have got two electron withdrawing groups, and here you can see there is no other group as withdrawing. So, one thing is very clear. Out of these two only, the one which will have the fastest or will be more reactive. Now, the second point comes is reactivity of halides. Now, like that we know that aryl halides mein iodides are more reactive, but when you talk about reactivity of aryl halide towards ARSN reaction, we know that aryl fluoride is more reactive than aryl chloride. Aryl chloride is more reactive than aryl bromide. Aryl bromide is more reactive than aryl iodide. So, as per this discussion, I think so you have got two different leaving groups. One is bromide and one is chloride. Normally, which will be more reactive in this reaction? I think so the answer is B. So, the correct answer for this MCQ is B. I hope this is clear, child. Let's proceed with the next question. Now, child, what you can see over here is among the following free radical bromination reaction, select those in which secondary halide is the major product. Now, basically, child, these type of questions are what? Where you can see, you have to just check in this example, each and every entire carbon atom, all carbon atoms are of the same type, that's a secondary. So, this is the one which can give you a secondary halide as a major product. Now, when you see in this case, child, you have got different carbons. You have got this carbon atom as a primary. You have got this as a secondary carbon. You have got this as a secondary. This one is tertiary. This one is secondary. Now my question to you is, there are 4 different probabilities to get, but out of this the major would be the tertiary but not the secondary. So this cannot be the answer. Now come to the next answer. Now whenever you have got bromine in presence of light, do you remember this is called as allylic halogenation, and in this case also child, you will get this as your major product. Is it clear? So even R is also correct. Now let's see the next one. Now in this case child, if you see the example number S, again it's a light and bromination. So here you have different carbon atoms. You have got a primary carbon, you have got a secondary carbon, you have got a secondary carbon, you have got secondary carbon, here you have got tertiary carbon, here you have got secondary, and here you have got primary. So there are so many different carbon. That means of course your secondary cannot be the major, it will be tertiary who will be major in this case probably. Yes, and they have asked where you will have secondary. Now in this case child, if you check this carbon atom or any other carbon atom of this ring, if you check, they all are secondary carbons. Is it clear? Now this carbon atom you have is tertiary, and when you see out of secondary and tertiary, the major has to be a tertiary, because here free radicals is formed and tertiary free radicals are more stable. So now last option which is left out, yes, in case of you can check, you have got primary carbon, here you have got secondary carbon, here you have got a secondary carbon. So out of 2 options, primary and secondary, you tell me which will be more stable. I think so, yes, secondary free radical, hence your secondary will be major. So in this case also your secondary is major. So which are the options where secondary is major? P, R and U. P, R, U. That means the other option what you can see, T can form so many products, but secondary will not be major. In this also S, secondary will not be the major product. So your correct answer in this case is your B. Is it done child? I hope this is clear. Let's proceed with the next question child. Which of the following compound is most rapidly hydrolyzed by SN1? Now basically when you talk about SN1 child, you have to think about the first step. What is the first step child? Your leaving group goes and it leads to formation of a carbocation. And I think so, what is the concept? Reactivity towards SN1 is directly proportional to stability of carbocation. Now see everywhere, if you try to remove from here, if you try to remove Cl, the group what are you going to get is nothing but a phenyl carbocation, and we know that phenyl carbocation is least stable. Achha, in this case child, when a Cl goes out, will I get nothing but the answer as CH2, CH, double bond CH2, and here you will have a plus charge which is allyl carbocation. In this case child, when a Cl goes out, I think so you will get nothing but C6H5. Here you will have C6H5. Here you will have C6H5 and with a plus. Now in the last example child, when you remove the Cl out, I think so you will get nothing but C6H5 and CH2 plus. Now if you see, out of all these examples child, here this example, this carbocation will be the least stable, or you can call it as least stable or unstable, whereas we have to find out which is most stable. I think so this is going to be the most stable. The reason why most stable, because over here you can see your positive charge is in delocalization with this benzene ring, even delocalized with this benzene ring, and even delocalized with this benzene ring. So on each ring you can have delocalization 3 times. That means overall it can have 9 resonating structure apart from the original one. That means over here this is more stable. Most stable means this will be the most reactive. That means the correct answer where the SN1 reaction will be fast would be the answer C. Is it done? I hope this is clear. Let's proceed to the next question child, what we have. Now, this question is again what? You have got over here a lithium aluminum hydride. Now lithium aluminum hydride is nothing but a very good selective reducing agent which will reduce your aldehyde, even can reduce your ketone, and even can reduce your ester also. Now what should be the answer? Point number 1. Ketone always will get reduced to give you a secondary alcohol. Aldehyde will always get reduced to give you primary alcohol. Correct? So out of these 2 situations, first of all you check. Here you don't have any change. That means this cannot be the answer. Correct? Now, aldehyde should get converted to primary alcohol. Here again, if you see aldehyde is unchanged, that means this cannot be the answer. Now, only the last part which is left out is esters on reduction, what it does. I think so, esters on reduction. From here, if I remove this leaving group, will I get first as H and H. So, you will get aldehyde, and this aldehyde later on gets converted to primary alcohol. That means all three compounds has to get changed. Yes. So, all three functional groups, see here this and this has changed, but here this part has not changed. That means this cannot be the answer. Your correct answer has to be C. I hope this is clear, child. It is nothing but a simple reduction of aldehyde and ketones, and along with that even ester is also clubbed. Let us see the next one. So, the next question what you have got, child, it is again what? Based on lithium, aluminum hydride and rann nickel. Now, basically child, you should know one thing. Lithium aluminum hydride is the one which do not attack carbon-carbon double bond. That means your this group should not be changed with lithium. Now, they have told you to find out the P1. Now, see over here, if you see the first example, your double bond is not there only. That means this group has reduced double bond. That is not possible. In this case also there is no double bond given over here. That means this is also not possible. Now, one more thing. Out of these two reagents, if you see, lithium aluminum hydride will always reduce your ketone, yes, but not double bond. Whereas rann nickel will reduce both of them. That means both of them should have different answer. I think so. The most appropriate answer in that case is what? See, your lithium is not affecting double bond, it is as it is, but your secondary ketone gets converted to secondary alcohol. That's correct. This is correct. Now, when you talk about Q, with H2 with PT, it's catalytic hydrogenation. Even a double bond has got reduced, and even your ketone gets reduced. So, even this answer is also correct. That means the correct answer for this MCQ has to be D, not even C. I hope this is clear, child. Let's proceed with the next question, child. Now, this is one of the very common reaction, child. I think so. We have got over here HBr. Now, HBr will carry out substitution of alcohols, but not phenol. So, alcohol is this one. So, will it get replaced by Br? So, first answer is very clear. Your OH will get replaced by Br. Now, I think so. The first case OH gets converted to Br over here. In this case, if you see, it is changing. OH has remained OH only. So, this cannot be the answer. Yes, sure. And I think so. This can be even the answer. So, right now one option is eliminated. Let's see the second one. Now, when HBr is treated with this phenol, again it will not react. But yes, ether, aromatic ethers will always gives you phenol as the answer. I think so. You are aware about this. So, your second option should be a benzene ring with 2 hydroxy group, and the position should be 1,3, which is resorcinol. I think so. The first example it is observed. In the second example it is not observed because both of them have been substituted. That is not possible. Over here also, child, one of them is and one of not. But both these answers keys are not there. Your correct answer is A. I hope this is clear, child. Let's see the next question, bacha. Yeah, the product of the reaction PH2C double bond O, and the reagent given to you is lithium aluminum deuteride and with water. Now, child, if you remember in a class, I have discussed the mechanism of this. It's pH, C and pH with a double bond O. Now, over here I have with us is lithium aluminum deuteride. Now, when you talk about deuteride, the attacking group what you have got is nothing but D minus, correct? And we know that aldehyde and ketone likes to undergo nucleophilic attack. So, what will happen? Your D will get attacked over here. This electron pair shifts up. So, the answer what you get is nothing but pH, C, pH, and here you will have D, and here you will have O minus. Now, what you have got next? On the arrow you have got nothing but your water, acid hydrolysis. So, it will act as a conjugate base which will take that H. So, your answer has to be pH, C, pH. Here you will have D and here you will have OH. So, the correct answer, I think so, would be the correct is when you write this in condense, your this answer has to be the appropriate. So, your correct answer key is the answer A. I hope this is clear, child. Let's proceed with the next question. Now, before we start anything, I think so, child, you should be aware that this is a carboxylic acid and this is an alcohol. So, whenever an acid reacts with an alcohol, it forms ester. Now, what is the logic to be remembered, child? If you remember, just see, I have got a carboxylic acid. Over here also carboxylic acid. Now, I have got alcohol. Now, which is that alcohol, bacha? I think so, you have got ethylene glycol. So, I will take that ethylene glycol. Now, this ethylene glycol has got one very special thing. You have got radioactive oxygen. Now, when this reaction takes place in presence of H plus ion, what should happen? You should know one thing. Always during esterification, your OH part is lost from the acid and H part from the alcohol. OH part from the acid and H part from the alcohol. So, the structure would look like as, you have got over here C double bond O, C double bond O. Here you have got, child, it's an oxygen, again oxygen, then you have got CH2, you have got CH2. Now, the question is, the ester you have, oxygen will be having a radioactive 18. So, your correct answer out of this has to be, the most appropriate is option B. So, what is importance of this answer? The important part of this answer is what? During esterification, OH part from acid and H part is lost from alcohol. I think so, you have understood this or you are clear with this. Let us go to the next question, bacha. Now, see, the next question given to you is what? I have got a benzene unit, correct? It's a benzene unit. Now, to that you have got a first reaction called as methyl chloride treatment, AlCl3. Now, child, if you remember, benzene likes to undergo electrophilic substitution and these conditions indicates it's a Friedel-Crafts reaction, Friedel-Crafts alkylation. So, what will happen, child? The first product what you will get is nothing but toluene unit, where benzene is having CH3. So, this becomes your product P. Now, when this compound is heated with NBS, child, what will happen? You will have got allylic or benzylic halogenation. So, this position will get halogenated. So, the product obtained would be, over here I have got a cyclic compound having CH2 with Br. Now, this becomes your product number Q. Is it clear, child? Yes. Now, let us come to the next one. This compound on treatment with OH minus ion, I think so, it's nothing but a nucleophilic substitution where this is delta plus and this is delta minus. So, this will attack over here, your Br will go out. So, you will get nothing but your answer as benzyl alcohol as the product formed. I hope this is clear. Now, this becomes your product R. Now, the last part. Can this compound on treatment with MnO2, child, do you remember MnO2 is nothing but what? Oxidizing agent. A mild oxidizing agent, yes, used specially for allyl alcohols, benzyl alcohols and propagylic alcohols. So, here we have got benzylic. So, here what will happen? Both these H's, what you can see, will get removed and you will get nothing but the answer as primary alcohol on oxidation gives aldehyde. I think so, this aldehyde, while naming system can be even called as carbaldehyde as a suffix name, when aldehyde carbon is not the part of the parent chain. That means this compound, a UPSC name is benzene carbaldehyde. So, your correct answer in this case is B. I hope this is clear, child. Let us proceed with the next question, Bichar. Now, Lasagne's test for the detection of nitrogen will fail in which of the cases? Now child, when you see this Lessagnus test is nothing but what? Whenever if you have got a sample and that sample is first heated with sodium metal, or you can call it as heated in terms of fusion or fused with sodium metal, and you get something called as sodium fusion extract, correct? Now the second point is what child? For a detection of nitrogen, yes, for a detection of nitrogen, if your sample contains a nitrogen, what happens when a nitrogen and sodium along with of course a carbon atom gets joined, you will get nothing but what? A sodium cyanide which is formed in the sodium fusion extract, and this is used further for that detection of nitrogen. But the problem is what? For this you require what? Carbon, and I think so over here in all these examples you can see nitrogen with carbon, nitrogen with carbon, nitrogen with carbon. So everywhere it can form, so it can show you nitrogen test, but this is only one compound where you can see there is no carbon, hence no formation of cyanide, hence no estimation of nitrogen. That means this is the one compound which will fail to give nitrogen test by Lessagnus method. I think so. This is clear. Is it done? Let's proceed to the next question, Bacha. I have the next question as child, a set of reaction given to you. Now first step what you can see is what? It's C2H2. Now C2H2, when you compare, this molecule has to be an ethylene, a molecule has to be acetylene, mistake, acetylene is the answer. Now what is the next step given to you? It's the treatment with HgSO4 and H2SO4. Now this is nothing but known as hydration of alkynes. Now when you do hydration, child, what you will get? I think so you have to add a water in such a manner that one side you have got H2 and one side you have got O. So here the product obtained is CH3 and CHO as an aldehyde. So the first product what you have got P is an aldehyde. Now this compound on oxidation further, and we know that aldehyde on further oxidation gives carboxylic acid. So here you will get an acetic acid form. I think so that's your question. What is the product? Q. Now this Q on treatment with SOCl2 in presence of pyridine. Basically we know that this reaction is used to convert your OH group into Cl. So in this case what happens? Your OH group gets converted to Cl. Now let's see that what will happen. The product obtained is acid chloride, which is nothing but my product R. Now last step, I think so this has to be treated with diethyl cadmium. Now child, if you know one thing, that acid derivative likes to undergo nucleophilic substitution. This is nothing but what is called as leaving group. Here this carbon atom is delta minus, here that's a delta plus. Whenever if you have got organometallic compounds, your metal will be a positive part, so your ethyl part will be the negative. That means it acts as a nucleophilic source. So can it attack over here? So your Cl will go out. So the product obtained in this reaction would be CH3, C double bond O, and the new member which has got substituted is ethyl part. Now when you write ethyl, can it be like this, child? Correct? Since you need to do balancing of this reaction which I have done over here, so you will get nothing but 2 moles of the product. So the final answer, which is nothing but a product S, is ethyl methyl ketone, which I think so as per the option what you can see is butanone. I hope this is clear, child. So this is one of the very common reaction. Let's proceed with the next one. Now child, question number 14. Now when you see this molecule, child, one thing is very clear. Here the compound is monocyclic. Here each and every compound is bicycling. That means this is nothing but intramolecular reaction. Now, how to form a ring? Let's see over here. The first step what I have with us is, in this case, I have got over here a benzene ring. I have got over here a carbon atom with a Br group over here. And here you have got an aldehyde. And I am going to treat this with 1 mole of methyl magnesium bromide. Now basically what happens with this? Basically it happens like this, child, that your methyl part, yes, gets attached over here, because this carbon atom is nothing but your delta plus electrophilic carbon. This is delta minus. Here it's the nucleophilic part. So here it has attached. So your magnesium part will come and join over here. So the structure what are you going to get would be of this type, where you will have a benzene ring. You will have over here a Br. Here you will have got a CH. Here you will have CH3. And here you will have O with Mg and Br. And since we know it's a type of a salt where you have got this plus part and this as a minus part. Now I think so you should understand, child, if you have got an alkyl halide which likes to undergo nucleophilic substitution, this is going to be delta minus, this is going to be delta plus. This can be a nucleophile to attack. So your Br will go out along with this. So your product has to be a cyclic ring with, this is the carbon shown. Here this is nothing but CH shown with a CH3 part. Here it's an oxygen which is there. So here what you see, this is going to get joined and you will get some byproduct, and that byproduct also would be nothing but MgBr2. Important is not byproduct, important is the product. So this is the correct answer for this MCQ. So what should be the correct answer, child, as per the option? Yes, the answer is B. So correct answer for this question number 14 is B. Let's proceed with the next question, child. Now here, child, what they have given, which carbonyl group below forms a single semicarbazone when allowed to react with semicarbazide. Now before we start anything, child, let's take a carbonyl group, treat it with semicarbazide. Now what is semicarbazide, child? It's nothing but a type of hydrazine molecule in which your H has got replaced by an amide group. So this is nothing but known as semicarbazide. Now what happens in case or in presence of weakly acidic medium, your this part O and this get lost. It's a nucleophilic addition elimination reaction, or which we call it as condensation process also. The product obtained would be C double bond N, then you have got NH, then you have got over here as CO NH2. Now the question is very clear, child. Suppose if I have got over here as R1 and R2 as a two different groups, will I get over here also as R1 and R2 as a separate group? Acha, you know that C double bond N type of a compounds, C N type of a compound can show geometrical isomerism. Yes. So what I can do is one more thing. Can I write this NH part over here? And what you can see now is, can I have the connection with a nitrogen like this? Can I have a connection with a nitrogen like this? And it has got one lone pair also. Now my question is, can this molecule can show geometrical isomerism? Yes, probably your R1 and R2 should be different, then geometrical isomerism is possible. Now the question asked is, now when a geometrical isomerism is possible, then this compound can have two isomers. One can be a syn and other can be anti-isomer. That means both the groups attached should be different. Now come over here. I think so. A carbonyl group, both the groups are same if you check. both the groups are same, whereas in this case groups are different on both the sides. In this case also both the side groups are different. In this case also both the sides are different. So when the groups are different, they will have two different isomers, whereas in the first example, since both the groups are same, it will not show geometrical. That means it will have only one isomer. So your correct answer, what I have asked, is a single semi-carbazole formed. I think so the correct answer is A. I hope this is clear, child. Let's see the next question, Bicha. In a given reaction, the sequence B is, they have given one reaction, child, if you know. What is that? I have got a benzene ring over here and which is attached to a cyclic compound having a double bond. They have given the first step as ozonolysis. Second step is nothing but zinc hydrolysis. Now we all know, child, what will happen in this case. Your bond will break. Here you will get O and here you will get H2. Is it first of all, sorry kids. If you remember, it's ozonolysis. So both the places I'll get nothing but aldehyde only. Now how to react? Let's see, bacha. That means both the cases I've got aldehydes. So I have got a benzene ring. I have got over here a double bond O. It's an aldehyde. Over here I have got one aldehyde molecule. Is it clear? Now what is the second step, bacha? I think so the second step is nothing but OH minus and heating. Now before we start anything, child, you should be aware that whenever there is an aldehyde ketone and a base given, first of all you need to check it's either aldol or a Cannizzaro reaction. Condition is what? If alpha H is present, it has to be aldol. If alpha H is not there, it has to be Cannizzaro. But now if you check this carbon atom, there is an alpha H. That means what will happen? If you remember a shortcut, your oxygen of a carbonyl and 2 hydrogen of this will be lost. So the product obtained would be of this type. You will have got a benzene ring. Correct? It's a benzene ring which you can see very clearly. Correct? Now here it's a double bond, here it's one carbon, here it's a second carbon, and which is getting joined with that only. That means it's nothing but this type of a compound where it is attached to one aldehyde. Not only this, bacha, before this also you can get your answer, because always in the final product of aldol it has to be alpha beta unsaturated aldehyde or ketone. Now if you see all these examples where you can see you have got an alpha beta unsaturated aldehyde only in one example, that means it's very clear this is only the correct answer, but I have even solved and shown how this product is obtained. I think so this is clear, child. Yeah, let's proceed with the next question then. Now the major product H in the given reaction. Now let's write the reaction, child. I think so they have given CH3, CH2. I have got over here a ketone unit and I have got over here as CH3, correct? Fine. So can I put it to CH3 over here? It's one and the same. Now it has to be treated with cyanide. Yes, Cn minus. Now we know that one thing very clearly, that this carbon atom, what you can see is an electrophilic carbon. So what will happen in this particular case? You will have nothing but your H attached over here. Yes, so this electron pair shifts over here. So the answer what you get is CH3, CH2, CH3, then you have got Cn over here and you have got O minus. Now the next step what you have got is 95% H2SO4 So the product will be what? Over here your protonation, that is a conjugate base, will take that H. So your answer will be CH3, CH2, C, Cn. Here it's a CH3 and here you will have OH. Not only this, bacha, further they have given even heating, and whenever if you take a concentrated sulfuric acid with heating, it indicates it's a dehydration reaction, child. And whenever you do dehydration, this is a leaving group alpha, and from the next carbon atom beta, your H will get released. So you will get a pi bond form over here, CH3, CH, double bond C, Cn and CH3. So your correct answer, I think so, as per the correct option, is B. Is it clear, child? I hope this is clear. Let's proceed with the next question, bacha. I think so on the screen you have got a next question, which is question number 18. Now, what is this question, child? I think so you know that we have got a toluene unit. Now, how toluene unit look like? I think so it's a benzene with CH3. Now, on the arrow we have got something called as KMnO4. Now, what this KMnO4 will do? It's an strong oxidizing agent which will oxidize your alkyl to an acid. So, can I call, you will get nothing but benzoic acid. This becomes my product A. Now, this benzoic acid has been allowed to treat with SOCl2. Now, what this SOCl2 does? Yes, it will convert your OH into Cl. So, you will get your answer as benzene containing C double bond O and Cl. I hope this is clear. So, you have got a second compound as a product B, which is benzoyl chloride. And the last reaction is one of the well-known reaction, child, where you have got H2, PD, along with that you have got barium sulfate. I think so here this reaction is something called as Rosenman reduction, where you will have a reduction done at Cl part, because here this is a leaving group. So here you will have 1H, here you will have 1H. So the product obtained is nothing but aldehyde obtained. So can I call over here the product is benzaldehyde? So I think so the correct answer as per the example is option D. I hope this is clear, child. Let's proceed with the next question. Now, child, in this particular case, if you check, we have got a starting material as pent-1-ine. Now, when you write a pent-1-ine, basically, how to write pent-1-ine? Can I put in a bond line? That would be better. How many carbon atoms I have got with us over here? 5. So 1, 2, 3. Yes. And the fourth carbon atom would be something like this. Correct? Now, treat this with sodamide. When you read this with sodamide, I think so you will get a salt formation first. So what will be that salt formation? Something like this. Something like this, where triple bond is there, and from here your H will be lost. So you will get this as a negative part and this as a positive part. Now this is nothing but a salt formation of an alkynes. What is the next step? I think so we have got a treatment of N-propyl bromide. Now after treatment of this, what will happen? We know that here it's a delta minus, sorry, plus and delta minus. Can it undergoes a nucleophilic substitution? So your Na and Br will get lost. What would be your main product? Let's see. So here you will have 1, 2, 3, yes, 4, and the fourth one is a triple bond, where you can see. After that you have got connection of 3 carbon atoms. So this carbon will be connected to 3. 1, 2 and 3. So this is my product. Now if you check, this molecule is exactly a symmetrical one. You can see 1, 2, 3, 4, 5, 6, 7, 8. So can I call this molecule as oct? It's an ine. Now On which position you have got triple bond? 1, 2, 3, 4, 1, 2, 3, 4. So it's a 4 ion, which is a symmetrical alkyne. Now last step, I think so something else is also to be done. What is that? I think so we have got this condition HgSO4. Now we know that it's whenever Hg plus 2 and this. I think so it's what? Addition of water molecule according to Markovnikov. So we have break this bond. One side you put it O and one side you put it as H. I think so you'll get ketone in this case. So let's write 1, 2, 3, 4, 5, 6, 7, 8. And the position where you can see is nothing but a ketone and this side H. I think so the correct answer as per the option what you can see. See, first of all, this reaction where you don't have aldehyde form. So aldehyde is not obtained. This is also aldehyde not obtained. So your correct answer has to be B as per the option key what you can see. So your correct answer is B. I hope this is clear, child. Let's try the next question. Now very good it is. An organic compound C3H6O. Now if I write C3H6O as the compound, does not give 2,4-DNP test, does not give. That means this indicate one thing, that your given compound is not aldehyde and not a ketone. I think so this is clear. Is this a clear? So first thing is very clear that your compound cannot be aldehyde and ketone. So let's first of all try to remove these options. Even try to remove this option. Now only two options are left out. Yes, let's see what. Even what has been given, this compound does not react with sodium metal. Even does not react. That means this compound even cannot be alcohols. ये alcohols भी नहीं होगा. Is it clear? So even this option is also not there. So only one option is left out. I think so your correct answer is B. I hope this is clear, child. Let's take the next question, child. Now these last 5 questions are numerical based questions. So let's see what we get. Now question number 21. Methyl cyclopentane on treatment with chlorine in sunlight undergoes free radical chlorination reaction. Let's now write this. I think so what you have got with us, it's nothing but cyclopentane and over here you have got methyl, correct? Now this compound on chlorination, now when you do chlorination in presence of light, it's expected you can have many products, correct? Now the question is how many products you can get. The first thing, one of the product you can get is primary, one of the product what you can get is tertiary, one of the product what you can get is secondary and another product what you can get is a secondary, correct? Now over here you have those 4 options which I am giving you, which are my products. Let's write the first one. I have got a 5-membered ring with one Cl group, correct, but on the primary carbon, correct. Now the second one, I have the next example where it's the tertiary carbon. Now the next example where I have is a Cl on this carbon atom, correct. The next example what we have is a Cl on which carbon atom? On this carbon atom, correct. Now what they have given, how many of the above monochlorinated product upon treatment with alcoholic KOH solution can give 1 methyl cyclopentane, correct, as one of the product. Now let's carry out one thing. Carry out in all these reaction treatment with alcoholic KOH. That means you have to carry out elimination everywhere. Let's see after elimination what you get. Here also I am doing the same. Chalo, let's write the product. In the first case, I think so after elimination, the product what I'll get is of this type. In a second example, when elimination took place, you will get this type of a product as the major product. Is it clear? Yes. In the next example, child, again, as per the elimination, Sedgwick elimination rule, you will have this as a leaving group. Now, the major product obtained will be this. And in the last example, what will happen? From here, your Cl will go. And again, you can have the product over here also as well as over here. So, the answer in this case would be, if I put over here this as a major product. Now, my question comes to is this, how many of the monochlorinated product on treatment with KOH gives 1-methyl cyclopentene as the major product. Now, 1-methyl cyclopentene major product is over here and over here. That means I have got two products over here. One is, I think so, this one, and the second one I think so is this one. Is it clear? So, ideally you can see there are two isomers, but if you see in this case, you can have cis and trans also. Yes. So, overall the number of isomers would be 3. Yes, 1 for this and 2 for this. So, your total number of monochlorinated product which can give you the answer would be answer 3. Is it clear, child? I hope this is clear. Let's see the next one. Now, this question is comparatively very simple. Among the following, the number of alcohols showing iodoform test. Now, iodoform test is shown by whom? First, can I have all alkane 2-on, all alkane 2-ol, exceptional aldehyde ethanol and exceptional ethanol, which is ethanol. All these can show iodoform test positive. One more important thing, when you talk about alkane 2-on, I think so these type of compound will come under this category. Alkane 2-ol indicates this type of category. You have got this type of a category which can show. So, let's now see. I think so the first example, methyl alcohol will not show. Yes, second example can show. Even this example can show because it's a propane 2-ol. This example is again a tertiary alcohol which will not able to show. This example is again a primary alcohol which will not show. Not. Now, in this example again it's nothing but a secondary alcohol. Yes, it's this type of situation it can show. Again it's a primary alcohol which will not show. This compound, if you see, it's pentane 3-ol. If you see, this again will not show. This compound again, it's a secondary alcohol 2-ol, it can show. So, how many compounds are there who can show? I think so. In this case, if you write, yes, the first answer would be this one, can show. Second is this one who can show. Third one is this one which can show. And fourth one is this which can show iodoform. That means your total answers are, your total answer is 4. Is it clear, child? I hope this is clear, child. Fine. Let's proceed with the next question, child. Now, how many moles of carbon dioxide will be released when the following compound is treated with or heated? I think so this type of question we have already done. I think so can I call this is nothing but your malonic acid derivative. So, out of these two, one of them will get decarboxylated over here. So, this is the first unit which will get lost. Second, out of this again it's a malonic acid derivative, dicarboxylic acid. So, again this particular part will give you one carbon dioxide over here. So, like that I have got 2 carbon dioxide released. Now, if you know that it's nothing but what, beta keto acid, and beta keto acid also can undergo decarboxylation. So, even this carbon dioxide is also released. Again this example is also beta keto acid, even this is also released. That means total number of carbon dioxide released, yes, will be 4. I hope this is clear, child. Fine. Let's proceed with the next question. Now, here I think so you can see very clearly, of the following carbonyl compounds, how many would give aldol condensation? Now, before we start aldol, you should know one thing. Aldols are shown by both aldehydes and ketones, and second important thing, it should have alpha H. Now, the question is, in which of the following alpha H is there? I think so here alpha H is present, so this will show. In this second example also, child, if you see alpha H is there, even this will show. So, there are 2 compounds. Yeah, here if you see, you don't have alpha H. You don't have alpha H. So, even this compound will not be there. Next, even this compound also, if you see, it's a functional group. Aromatic aldehydes generally do not have alpha H. So, even this is not. Even this compound, if you check alpha position, you don't have H. So, even this is not. Yes, in this compound you can see alpha H's are there, that means it can show. Now, in this example, child, if you see here, there is a carbonyl group, but on the other side you can see there is an alpha H. So, even this also can give you a reaction where intramolecular aldol will take place. In this example, if you see, carbonyl groups are there, but you don't have alpha H. So, no alpha H in this case. That means, if you see your correct answer, let's see the correct answer is what, bacha? In this, the correct answer is, this is one of the correct answer. In this is another correct. In this is the correct, and even this is a correct. So, over here there are 4 compounds which can show aldol reaction. I hope this is clear. Now, let's proceed to the last question, bacha, what we have on the screen. And the question is this. In the estimation of bromine by a carrier's method, 1.60 grams of an organic compound gives 1.88 grams of silver bromide. The mass percentage of bromine in a compound is. I think so this question belongs to chapter Practical Organic Chemistry. Let's discuss that. Now, here basically what is the reaction? Your reaction is such that whenever the organic compound, yes, which contains halogen, let's say bromine, it's treated with nitric acid followed by silver nitrate, what will happen? Your silver bromide PPT will be obtained. Now, the mass or the weight of silver bromide is considered to be as W1. Now, what is the concept? Concept is very clear. Let's see. The silver bromide molecular mass is 1, I think so it's 108 plus 80, it's 188 is the molecular mass. Now, the question is simple. 188 grams of silver bromide contains 80 grams of bromine. Therefore, W1 grams of silver bromide will contain 80 into W1 upon 188 will give me the grams of bromine. But now question is, they have told you to calculate the percentage. So, let's now see. The percentage of bromine to be calculated is the mass which is obtained into 100 upon the original mass of the compound. Now as for this, let's put the data. 80 is there. Now what is it? W1? W1 is nothing but the mass of silver bromide. I think so the mass of silver bromide given to you is 1.88. So can I take it over here as 1.88? Now multiply by 100 upon W. What is W? It's 1.6. Now it's a simple calculation, child. I think so you can cut 1.88, 100 and this. Now what are you left out with? You are left out with 80 and this, correct? 1.6. So what should be your correct answer in this case? Yeah, I think so the correct answer for this has to be, yeah, anything else is left out in this, child? No, I think so this is 1 and 80 it's nothing but this, so it has to be 50%. So your correct answer for this is 50%. I hope this is clear, child, correct? So hope so you must have understood this, and still if you have got any doubt, you can come down to branch whenever you feel it comfortable. Yeah, thank you very much, child.